Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Omoka. I am your instructor. Today, I'll be showing you the Raft Foundation design for this school building. So this is the part 2 of this Raft Foundation design. Yesterday, we did the part 1, which is to model this Raft Foundation, where we have to model this ground beam and then also model this raft slab here, and then now model for this slab tool under this place. So if maybe you missed the part 1, I would say you should check on our channel or check on the link down below and watch the part 1 of this Raft Foundation design. So today, this is the part 2, which will now begin the Raft Foundation analysis and design. So right now, let's get started just now. So for now, to begin the design for this Raft Foundation, I'll go onto this place first and go to plan view, and under my plan view I'll be on story 0. As you can see it here, story 0 is for foundation. So first of all, I'll turn on my grid lines. I turned it up before just to give some clarity so that you can be able to see the 3D view modeling very clear. So right now on this place just now, the first thing to do again, once you reach this stage, once you've gone to this place, before you begin your Raft Foundation analysis, you have to draw what they call slab strip. So I have to click on this place right now, on this place, concrete member, as you can see it here, then go to this place, slab strip. Now, on the superstructure, which is for the first floor or second floor, you have to finish your design before you can now draw your slab strip. But for Raft Foundation, after you finish modeling your Raft Foundation, like placing your beams and your slabs for the raft beam and slab, then you have to cut your strip first before you can begin your Raft Foundation design. If you don't cut your strip first, then after your design for the Raft Foundation, you won't be able to cut the strip again because you won't be able to see the reinforcement of the Raft Foundation slab. So right now, I'm going to cut the strip. Now, the way we used to cut strip on the superstructure, we used to use this type, which is called an Antiga slab. But for our foundation, we used to use FE strip, which is finite element method of strip of slab detailing, which is strip. So I have to go here right now and then click on this place, FE strip. So this is used for only Raft Foundation or for a flat slab design. So right now I'm going to use this one here, FE strip, and then once I do that, I'll check my X direction, as you can see it here, and then now I will just cut. I will pick this place and this place here. Now since this toe reinforcement is not the same thing with this slab raft reinforcement, and since they are of the same level, that means they will not detail the two together. So I'll have to start my cuttings of the slab detailing from this point and not at this edge here. So I'll quickly start it from the very point once I pass the slab, this beam here. So I'll click at this point just now and then go over to the next point since I'm cutting X direction, and then go hold my control key to make my line straight, and then I'll hold my control key and then click at this point here. Okay, so right now I have cut my X direction. I'm not going to cut every panel because the whole idea is just to get the value of my slab reinforcement spacing and also the size of the reinforcement. Then once we get these two values, we will now going to use the customized stone bridge, the customized Prota structural detailing template, which is the stone bridge template, to now perform this Raft Foundation design, which I also do on the part 3 on the Raft Foundation detailing. So we are going to use the stone bridge customized structural templates for detailing of this. So if maybe you need that template, you just check on the link down below. I'll also drop the link for that template also, so that you can be able to follow up together. Okay, so I'll just go again right now and click on this place here. I'll not cut for the y direction. I'll do the same thing again. Go here and click up here, and then go over to this very down place here. Hold my control key down, and then click at this very point here. Okay, I can just cut again on X direction and cut this other one. I can cut from here again to this very place here. okay, for X direction, and then cut also this panel again. The whole idea is just to get my slab reinforcement design reports and also the spacing and the size. Then we will now use the stone bridge detailing template to now perform the Raft Foundation detailing. Now, stone bridge detailing template is a customized template used for structural detailing after you're done with Protastructure. It works perfectly well with Protastructure. In fact, it was customized basically for this software Protastructure. So if you need that, check on the link down below. It's not free, but it will help you a lot because it will have to reduce your work to at least 80%. Okay, so right now, once we are done cutting this slab strip right now, the next thing to do, I'll have to save first. So always save so that you will not have to lose any of your job in case the software runs into runtime error or shuts down. Okay, so on the part one, I said that for you to choose a Raft foundation as your choice of foundation, that means that the bearing capacity of the soil is very low. And for you to make a choice of Raft foundation, your bearing capacity must be lower than 75 kilonewton per meter square. So once your bearing capacity is lower than 75 kilonewton per meter square, then you have to make a choice to use a Raft foundation or a strip foundation. But the best choice to make is to use a Raft foundation. If it is for a bigger building, use a Raft foundation. If it is for a very small building, you have to use a wide strip foundation. And if that is not if that wide strip fails, then you can now go ahead and now use a Raft foundation. Okay, so right now we have cut our strip X and Y direction, and also we have also saved. So right now I will now go to this place here called analysis, and then click on this place here. This one here, finite FE, which simply means finite element, as you can see it here. FE Raft Foundation Analysis. So I'll click on this place right now and wait for the dollar box to appear. So on this place right now, I'll just check these three values here, these three checks here, and then leave here as default because this is the average search charge. So I'll just go here right now, leave here as default as it is there. It's good as default, and then click on this place here, Raft Foundation Mesh and Analysis. So I'll click on this place here right now. Don't click on this space over, else you begin to have pause on your design for the Raft Foundation. It now begin to pause on each level. We mainly use this if you're designing for a super, let me say, for 10-story building, 15-story building, for a high-rise building. Then we can now use this, that when it gets to that, it can only it will be performing the floor analysis level by level. Okay, so right now, once on this stage just now, we'll now click on this place here called generate model. So I'll click on this place right now, leave these two values as default, leave them, just click on this place, generate model. So once we are done with creating the mesh model, we will now move on to the next stage, which is the post analysis and design. We will now have to click on the contour and then begin to check for our bending moment, and also check for our area of steel for the bottom and also for the top, and then go ahead now and check our soil pressure, where the building pressure must be less than the soil pressure. Once the soil pressure is more than the building pressure, once the building pressure is more than the soil pressure, then it shows that there is a failure on your Raft foundation. But once the soil pressure is once the value of the soil pressure is more than the value of the building, of the pressure due to building, then that shows that your Raft foundation is okay. Don't worry about that. Don't panic about that. I will just show you all that what I've just said right now on this design. Okay, so there is what we call Ekidel mentorship class. So if maybe you are interested to like enroll for our special training, then you can just check on the link down below and then click on the link which says join our Ekidel special mentorship program, and then we will train you specially for the design of structural elements. Okay, so right now, once you're done this stage right now, you can see that it has shown that mesh generation completed successfully. So right now you have to now click on this place here called close, and then once you click on that, you have to wait for the next stage to open. Don't click on anything. If you click on anything, the software will tend to misbehave. So wait for the next stage to open. Okay, so just hold on. Once it opens, this post analysis here will be activated. So just hold on for it to open, and when it also when it opens, you will be given the chance to put in your soil bearing capacity, which is called in this software arrival soil bearing capacity. So you have to wait for it to load up to the next stage. Don't click on anything and then wait for it to load. Okay, and then you will also see what they call positive moment and also negative moment. Leave those two values as it is, 1 just impute your soil bearing capacity, which I have said already in our part 1 that you have before you make a choice for a Raft foundation, that shows that your bearing capacity must be below 75 kN per meter square. Once it is above that, you have to use a pad foundation or a different kind of foundation. But once it is below, you have to consider using a Raft foundation or a wide strip foundation. Wide strip foundation is what what you should consider first. Then when there's a failure, you can now go ahead and now design for a Raft foundation. And when Raft foundation fails, you can now go ahead and now design for a slab raft. There is what they call beam Raft foundation and also a slab Raft foundation. Slab Raft foundation is the last foundation you will consider before you can now consider a pile foundation. Pile foundation is the last type of foundation that you can use for the design of structural element. Although there is also what they call a strap foundation, but that's not common. I will tell you when to use that as we go ahead on our videos. Okay, so right now you can now see this place called allowable soil stress, which simply means the bearing capacity of the soil. So in this case, the bearing capacity of this soil is 55. So I'll quickly put in the value right now, as you can see there right now, 55. And then once I put in the value, I have to click on this place here called analysis post processing. So click on this place just now, leave these two values as 1 and then click on this place. Okay, so right now, once you click on this place right now called, then just hold on for it to load the next stage. Now the next stage is what we do is where we are going to deal with the soil pressure against the building pressure. Okay, so let's just hold on for it to load just now. So if you have any comments from what we have done, if you have watched the part 1 and the part 2 and this part 2 right now, and you have any questions so far for what we have done, I would say that you should just drop the comment down below. We have been answering comments since we in all our videos, so just drop the comment down below and then we will just reply you ASAP. Okay, so thank you, and then let's just wait on for this stage to conclude. So now once this dialog box, once this meshing environment is okay, you will see all the yeah, this is how you see it. So everything now looks okay. So the first thing, once you come to this place, I would say you should just click on this place called contour. You can see that we have different contours here, but this is the one you should click, called standard contour. Don't click on this one and don't click on this one. Just click on this one here called standard contour. So I'll click on it and wait for it to load. Now once it loads, you will see this thing here. Now this is what you should be looking at as we are about to enter the next stage. So once you have clicked on this place just now and then begin to click here, as you can see it here, begin to click here now. I'll click here, and then once I click here, I'll allow it to load into this model here. So whatever thing you click here, you have to allow it to load. I'll click again on the next one again, and I will allow it to load. Now put your eyes here, you'll be seeing the values of everything we are clicking here. Right now we have clicked on the MX and on the MY, and you can see the value of the moment at Y and also at X. You can see this red one here shows the maximum value of what we are going to click, and this first value here shows the minimum. So always put your eye at the maximum, because in design we design for the worst condition. Okay, so right now I'll click again on MS and MY. We are going to be dealing with this when we enter this required steel area of steel. Okay, so but you have to pass through this stage first before you can get to this place. So I'll go now and click on M1 and then wait for it to load, and then once it is done, I'll now click on M2, and just that way sequentially. So I'll do the same thing right now for M2, and then go again and do the same thing for M1 and M2. Now this is a live project, as I said on the first on the part 1 of this video. This is a live project. It is a school project which we are designing for for a client. As you all know, here on Ekidel, it's our culture that we use a live project to cheat, because we believe that it is only when you use a live project to teach anyone that the person will have confidence for what he or she is learning. So that's why we use mostly live projects to design. Okay, and God has been helping us. We get projects almost every week, so that's why you see us making videos almost every week. Okay, so we go again right now and then click on this place and then click now. So once I click here right now, I will be able to see the area of steel on the button. So I will be now now you can now see that the maximum area of steel that we have is 1206, as you can see it here. So with this right now, let me just continue and then click on this place. Now if you check on your slab reinforcement table, which I believe you should have, you can be able to relate the you can be able to relate what spacing of reinforcement and the size of reinforcement that you will use. Although, because we have already cut strip before we get to this stage, I will show you how to produce that, how to see that reinforcement. Okay, so right now I'll click on the top one right now, because I've already clicked on the MD2 button, as you can see there. So I'll click on now. As you're clicking here, if your slab depth was not sufficient, you will be seeing error. Once you get to this area of steel stage, once your slab thickness is not sufficient, you will begin to see error like insufficient depth errors. So once you see that kind of error, you have to go and then locate that slab and then increase that area of slab, or increase the slab thickness generally only for the raft foundations. Okay, so I will go again. Okay, I've already clicked here. Let me allow it to load. Okay, now it have load. Now we will now go ahead and then click on the soil pressure. Now this is where you should pay very good attention for the soil pressure. You can see that. So this is the last one that we are going to click, which is this soil pressure here. Don't click on this soil pressure threshold. This soil pressure threshold, you are going to use it if you're using this threshold contour. But since we didn't use it, since we're using only this first contour, which is called standard contour, you have to stop you have to stop whatever thing you are designing on this soil pressure. Now this is the only place we are going to click, and then we will now begin to relate between the soil pressure and the building pressure. So I will also show you when now it is on this soil pressure, you will be able to know if your raft foundation is failing or it is passing. So let's just allow it to load. This stage alone takes a lot of time. This soil pressure, you can see how all these ones we are just loading one by one. It didn't take much time, but this soil pressure can take you up to 30 minutes. And if your system is not that strong, or your system capacity or your system RAM is about to be filled up, then you have to wait for sometimes 2 hours, 3 hours. And if the building is very, very massive also, this stage alone will take you longer time. As you can see that this building is already 35 meters by 25 meters. So this building alone is a big building, so that's why you are seeing it taking time. But what we will just hold on for it to load up. So once it is being loaded up right now, I'll begin to show you how to check how to know if your raft foundation slab is failing or not. Okay, so let's just hold on for it to load right now. Okay, like I said again before, if you have any question concerning for what we have done so far, I would say you should just drop the question down below. We have also dropped also our WhatsApp number down on this video description, so that you can also chat us up if you have any kind of confusion, and then we will like guide you through. But our advice, if you can afford it, it is only $20. We are giving a discount already for $300 for our special Ekidel mentorship class. So if you can afford that, that will be better, because we will teach you both manual and also practical, and then also teach you with software. Okay, so right now you can now see that the soil pressure has now been completed. So to know if your slab is failing, you can put your eye, you can just carry your cursor and hover around any of these places, or any of these anywhere around this building right now. As you can see that the soil pressure first, you can see this place, this is the soil pressure based, this pressure you're seeing here is the soil pressure based on the structure load. Now this is the soil pressure. You can see it here. This, all these values here is the pressure based on the structure load. Now the pressure based on the soil bearing capacity which we provided, look at it here. This one here, this is the, okay, so let me just hover again right now to see again this side again. Sorry, so this one here which is showing 77 is the soil pressure based on the bearing capacity of the soil which we provided. I don't know if you get me. Don't forget that we used 55 as our bearing capacity value. So since we are using a BS code of practice, so multiply 55 multiplied by the factor of safety of 1.4, that will give you this 74, this 77. So 77 is the soil pressure due to the bearing capacity. Now this pressure here is the pressure due to the load, the weight of the building on the soil. So how to know that your foundation is not failing? One is this. Once this value here, which is the maximum value here, which is the load of, which is the pressure from the building weight, is less than this value here. Once it is less than the value of the soil bearing capacity pressure, then your foundation is okay. Now as you can see here, we have 77. You can see there, and then our maximum here is 76.9. And if you check very well, if you can zoom this very well, you will see that this maximum here may not be directly on the area of the building. It can just be at the edge of the perimeter of the building. Let me just zoom up. Okay, so when you're trying to zoom up this right now, you will see that it will begin to seize as if your system is like hanging. So the whole idea, just to be fast, is just for you to collate this, just get the maximum of this, and then locate this maximum here for the soil. So once this value here, which is the maximum, is less than the value here, then your foundation is okay. So in this case right now, we have 76.9 here, and then we have 77 here. So with this right now, this foundation is okay. So the load, the soil pressure due to the weight of the building is less, as you can see it here, 76, is less than the soil pressure due to the bearing capacity. So with this right now, this Raft foundation is perfectly okay. Now if it was failing, there is something you would do. Okay, so right now, we don't expose that here on Ekidel. This is a free channel or free YouTube channel, but if you come to if you are able to enroll for our Ekidel mentorship class, we will teach you all the details that you are meant to know. Okay, so right now I've just showed you how to design for a simple Raft foundation. So right now we are not going to move in right now to close up to this stage and then begin to check for our Raft foundation slab reinforcement. Now this is also shown export contour. There is a stage, there are sometimes you have to export these contours, but not on this. That is if you're doing a very massive building, then this must be a must for you to export. Okay, but for now, since this is a small building, I'll just go ahead and then click on this just now. Okay, so click on this. Now the reason why we advise people to enroll for our mentorship program is because there are some things, since this is a free channel, there are some things we might not be able to say everything, but on our mentorship program, we train you very well and show you all the secrets and details to perform to be a good structural engineer or a civil engineer. Okay, so right now you can click on this place right now. So click on you have to click on this place here, say okay. So I'll click on okay and then wait for you to now transfer all the slab strip, which is the slab reinforcement, onto the very model. So once you reach this stage, just hold on. Once once this stage begin to read, you will begin to see the values here will begin to read. So just hold on for it to start. Don't, I say again, don't click on anywhere, because once you click on anywhere, it will make your system to slow or to hang, and most times the software can just shut down. And if the software is shut down at this very stage now, as we are here right now, everything you have done has lost. You will lose them because we have not saved anything, and you cannot save on this place. This place, if you want to save here, it will not going to save the main Prota software of your model. So you can see that we are now on the strip 1. So we wait for this strip 1 to finish, and then it now enters strip 2. Okay, now we are now on the Y1, as you can see it here. Then wait for it to end to finish. So that's how it will read till it finishes X2 and X3. Okay, so once this is done, it will now move it back to the next stage, which you now transfer the load of the slab onto the ground beam, and then we will now go and design our ground beam. Okay, so let me just hold on for that stage to just complete right now, and then we will now move on to the next stage. Okay, this is the last stage now. It's almost ending. You can see how it's reading here. Like I said before, once this stage starts, this place will start reading. Okay, so right now, so on this stage right now, don't just go ahead and close. You have to transfer the foundation beam result into the beam, into these ground beams. So I'll say now transfer foundation beam result. I can see right now they will tell you here that foundation beam finite element result are transferred. So right now we can now close this stage just now. Now once you close right now, you can now see that we have already done strip right now. So since we have already designed our slab foundation right now, we can now right click here to now see the slab, the Raft Foundation reinforcement slab. We can now just right click here and then go here and then say update T-bars. Okay, and wait for it to finish up just now. It will take like some few seconds to show the T-bars. Okay, so right now we can now move on once it is shown. Okay, so you can now see our slab. You can now see it, right? So it is showing that we are to use Y16 for the Raft Foundation. Okay, let me see if we didn't choose Y12. So let me go and check for this place. And sorry, we have to go and assign Y12 for that for our slab detailing. I think we didn't use Y12, so that's why it's showing just Y16. So let me go and check first. But although this building is a very big one, so if we see and that it's already assigned Y12, so and it's choosing Y16, that means Y16, because remember we had on that place called area of steel, we have our area of steel to be 1,200 and something. So if you compare it to what to your slab table, you will see that it is falling directly on the Y16. But let's see first if we assigned for foundation to use Y16 alone and not Y12. Okay, let this stage just pass, and then we'll go and check that right now. So we go to this place right now, this place here. Let me see, sorry, on the here, and then go to edit material, and then go to foundation floors. Let it come up. It's coming up just now. Okay, foundation floors, and then go to this place, rebar diameter, and then okay, can I see that we have only 16, so we have to go and assign 12 here. So we'll choose 12, as you can see it here right now, and then say okay, and then say okay again, and then say close. So with this right now, I'll just go here, right click here, and then again and say update T-bars, and then check if it will use Y12. Wait for it to finish up. It's still trying to load. Okay, so okay, now that's fine. So you can now see that it's not showing us Y12. Okay, that's fine. So you can now see that all our slab reinforcement right now is for the Raft Foundation is giving us Y12, and some parts spacing is 125 and some is 250. Although we can use 200 here on this place showing 250, and we also have some parts. Okay, almost every part is showing 200 except this one that we saw here, which is where is that 125 here. Okay, that's fine. So we have to take note of this here, and then take note of this. Okay, this one is 200. Okay, that's fine. So we will have to export this to the template, which is the customized Prota detailing template, which is called the stone bridge template, which I will also use. So you can now see how we have designed for our Raft foundation. Now we are going to now go and design for this beam, because this beam have not yet been designed. So we have to now go to this place here. To this, let me go and assign first for our, we have to go and assign first for also our beam reinforcement. So let's just save this first. Let's save this right now. So you can now see, so you have seen how we have produced our Raft foundation reinforcement for the slab. That's how to produce the Raft foundation for the slab. Okay, so let's now go and design for the beam, because all what we have done so far is just for the slab. It's just for the slab design, and not also to now transfer the load from the slab onto the beam. Okay, so right now we will now have to now go and design for the beam, especially which I'm going to use a batch mode design for the beam. Okay, let me just finish. Let's just round up just now, and for us to move to the next stage. Okay, now the part 3 of this building of this design will be on the detailing, because we have told the client that we want to issue this job to him by next week. So that's why we are trying to finish up this just now. Okay, so right now I'll go here right now and then say edit, and then check my beams, and then check my beams, my beam reinforcement, and then assign. Okay, I want to use minimum 16 and maximum 20. That's fine. I'll say okay, and then just say okay here, and then just say close. That's fine. So right now, once you're done updating your steel bars after you're done with the designing for your slab, you can now go right now to now go and check here settings here, and then not settings, on this place here, concrete member as concrete design, as you can see it here, and then go to this place here, and then go to foundation beams here, and then a little box will appear where you have to put some settings. So you can see that all our beams are failing on the foundation. You can see that F means foundation beam, so it is failing. That's how it is to show. So right now you have to now go to this place, click first on this place. Now listen here very attentively. If you don't do these settings here, there is no way your beam will design. If you don't put these cover values, it will not design. And you put your cover values on this sequence. You put for the edge the 35, and then you put here 50, and then here 35. If you don't put this value this way for your cover, this beam will not design. Okay, so right now you now go again right now, and then go to this place here, parameters, and on these parameters right now, you click here and then choose your minimum bar for the beam, which is 16, and then maximum to be 12. If you don't check this, there is no way this beam will design, not in heaven and earth. Okay, so you click here again right now, and then choose your maximum length. Just choose 12, but the design will use 10, which is the minimum, but you have to choose here first as minimum maximum. So the whole idea is to choose your minimum steel and maximum steel, and for length also minimum steel for length and maximum length also. Now once you've done that right now, you now click on this place here called save. It will share you this message. Just say yes, save. Now it has not changed to these settings which you have done for the beams, which is just for the foundation beam. Now on this right now, you can now go ahead and now click on this place here called batch mode design. So click on this place right now, and then check this first one here, check steel, select new steel when previous bar are insufficient. That's fine, and then click on this place here called calculate. Then you wait for it to design for the beams. Now once you're done designing, you will see that all these things will mark, not all actually, but few of them, or all of them will mark green good. Now once it has marked, you will now begin to check each of the beams, which I've taught you before, which I've taught you on the structure, what they call interactive design. So once few of them are being designed, we will now begin to check for interactive design, where maybe I'll have to check for the beams one by one. Okay, that's fine. So right now you can now see that all the beams have been ticked good. So you can now begin to check for the beams one by one. So just click here and then double click on each of the beams. Once it opens just now, you will now see the beam internal area. So this is how so I want to use 20 is too big for me, and also it will make the beam to be very expensive. So I'll just increase the bar to 3x16 and reduce from 20, remove here, and then increase here. So I'll also reduce here and then increase here, and then also on this place right now, I'm going to remove this right now, and then remove this also, and then I'll also come here right now. Now this thing is this reinforcement need to lap into this place. You can see that this red thing here means failure, and this also means failure. So right now I'm going to lap this reinforcement right now into this column. So I'll go here right now and click on this place and say lap, extend right to lap. Now reduce this first to 16 and increase to 3, it will pass, and then come here again right now, and then lap left to lap, and then lap here also to lap, and then decrease here and then increase here, and then come here again right now, and then click here and then say here lap, and then decrease and then increase. So this is how you are meant to set for your Raft Foundation. Most people do mistake and to leave support bars here. That will give you a rubbish as in when it will give you a rubbish detailing after you've exported your bin details. It will give you rubbish. So this is how you have to arrange it. Now this is the reason why we say if you can afford for our special training, you should afford it. For now, right now we are giving discount. It's not expensive, $300, which you can pay for 3 installments, and it is just a 4 weeks intensive program. Training. So we have to train you very well. Now you have seen what we have done so far on this bin. Most of you will just go ahead and leave it the same way as it was, which is not okay. So this is how you are meant to arrange your beams. Now there might be some things which we are not which we are not saying, because we don't want this video duration to be very, very long. That's why we advise, as you watch our free video, when you have made money or raise some money, I'll say you should enroll for our special training. We are not gonna you are not helping us. We are trying to impart what we know into you, and which we have already done so far on our free channel. Okay, so right now we have to now click on this place, say okay. So if you're interested, I'll say you should check on the link down below and then enroll for that. Okay, so right now it is now that we have now said that this first bin here has been designed for, because we have checked it. That's why it is called interactive design, as you can see it here. So you as a civil engineer, or you as a civil engineer or a good structural engineer, is meant to check the software to see the kind of reinforcement the software used to design for your members. So right now we check on this again. So always you have to check for the bins one by one to be able to be sure what the bin reinforcement will be at the end of everything. So right now, if you can export this right now as your bin result, you have seen that all the reinforcements are not arranged. You see a messed up detailing. So right now you have to arrange it by yourself. That's why it is called a software. Someone programmed this, and those people also make mistake. Okay, so right now you have to now decrease here and then increase the number of the reinforcement, and then decrease here and then increase here and then decrease here and increase here, and then remove this entirely from support, and then remove this also from support, and then go here right now and lap this first, lap this here, and then decrease here and then increase here, and then go here, lap left and right. You must lap, else you will see your detailing as a messed up. And that's why most people say this software is not good, because they don't know how to use it. Okay, so right now you have to increase here again the number of reinforcement, and then go and check again on this place. Come here, decrease the number, the diameter, and then increase. When you decrease, there will be a failure. This rating here means failure. If you go and print out your drawing like this building will collapse. So you have to increase to make sure that there is no red here, and also there is no red here. So here right now, remove this also entirely, and then come here and then lap this place right now into this, and then reduce the diameter and then increase the number. Okay, that's fine. Now remove this entirely just now. Okay, now when you try to remove, sometimes it's not going to remove, but this bar is already off. So if we say okay and then come back again and then check it right now, you will see that bar has already gone out. Okay, so you can now see that is out. So this is how you have this how your bars will like look like. You have 3 numbers up and 3 numbers down. This one is called a is called a web reinforcement, which is also called a sidebar. Now once your beam once your beam depth is more than 600, you will begin to see this kind of sidebar, because that is now called a deep beam, and this beam depth is already 1.4. so that's why we are having these sidebars at the side of the beams. Okay, that's fine. So right now we only touch the top bar and the bottom bar and leave this sidebar as default as it is. So right now click on OK. So you are meant to check each of the beams one by one. So you can now see that once you have checked, I have checked 1 and 2. So you are meant to check all of them. Let me check this one again right now for you. But the whole idea is that before you say you're done, you are meant to do all the checkings of what I'm doing just now for all these foundation beams. So you are meant to check them and reduce the bars if you don't want how they are. Make sure you have only the bottom and the top. Leave all this, take off all these support bars here. They will make your beam detailing to be a messed up and it will not look nice. Okay, so I will also come here, lap this one just now, and then reduce the bar, and then increase increase the number of the bar, and then come here again, the same thing again, lap again, lap left and lap right, and then come here again and then do the same thing here, and then come here again right now, lap left and then lap right, and then reduce the size of the bar and then increase the number of the bar. Okay, so right now again, I'll go again just now, remove this one entirely, and then come here again, come here right now, reduce the bar diameter and increase the number to 3. Now our 3 is still failing, so I'll make it to be 4. Okay, 3 is okay, but at the bottom here I need to lap it to stop this failure here. So I'll come here right now, lap it here, reduce the diameter of the bar and then increase the number. And this place here, I'll just let me check again. Okay, that's fine. Now this place right now, here right now, since you already removed it, it has gone off. But once you say okay and then come back, you will see it again. So I'll say okay right now and then come back to the beam again, and then check. You will see that beam, that support bar is off. So you cannot see that it's off because it was there before. So right now, this is how your Raft Foundation beam is meant to be arranged, where you have to have the top, or just the top, and the bottom. The top reinforcement, which is here, as you can see there, and the main bottom reinforcement, as you can see it here. So this is the main top reinforcement and the main bottom reinforcement, and then your sidebar. So this is the 3 bars you're meant to have: top bar, bottom bar, and sidebar. So you cannot see. Now if you print out this, if you now produce out this beam detailing, which you will see on the part 3 of this video, you will see how it will look like, perfectly and sweet. Okay, so right now I want to go here and click on OK. So I will urge you to use the same that example which you're using on design right now. Check all your beams, check all your beams one after the other. I'm going to pause video and then check that. The reason why I'm stopping is to make sure that this video duration does not pass at least 1 hour or it's less than 1 hour. If not, I will have checked all of them. But to do that, doing all just now will take much time for me, which I don't want to do. Take more time. And if I continue doing it, it will look boring because you will see that it is the same thing which I'm just doing just now. So the whole idea is for you to check the beams and do just what I'm doing just now. Reduce the size and then increase the number once it's failing. Now, once you reduce the size, there will be a failure. This thing here means failure, here means failure. So you have to now increase the bar number for you to be able to pass, and then it is okay with this. So you can actually go here right now, click on OK, and then go. Let me just go again. It's just you can see that it's just like it's just like tempting me to continue checking the bars, but I will not, because I have to stop these videos, that I'll save the duration, because the cost of making these videos and also uploading it on this YouTube, and when and each of the size of these videos, some of them is about 1 gig, 2 gig, and it's very expensive. Most time we spend much money to just buy data and then upload all these files. Okay, so so there is also a free link, because we are trying to create a website for Ekidel just to serve you better. So there is a free link for donation, which you will just put the amount which you want to help us and then assist us to support us to get this Ekidel website. So if maybe you want to support us, I will share you will see the link down below, say donate, so you can donate any amount of your choice and then help us to create this website, because we want to get the website this year. That is one of our that is one of our 1 year this year agenda on Ekidel, to have a website for Ekidel so that we can help you better, because there are some things which you are meant to do that we cannot do it here on YouTube, and those things will also help to serve you better. Okay, so right now go here right now and then reduce this and increase this. So if you love Ekidel, I'll say you should just use the support link and then support us to get that website. Okay, so let me just go again right now and then reduce this also, and then lap this first. Always lap, these two must be at lap and then increase this here. Okay, that's fine. So you can now see that there is nothing showing red on this side and also on this side. As you can see it here, everything here becomes very okay. So with this right now, I'll say okay. Now I'll have to stop here, but you have to check all your beams. Always check all your beams. That is an instruction, else you begin to have issues on your building design. Okay, so right now this is the way to perform a Raft foundation. So we have done it very full. And also on the part 3, we will produce the beam result and also the, okay, let me just show you how to produce the beam result right now. So to produce a beam result, I'll just click on this place here and then click on design report and then wait for it to load the next stage. So right now I'm trying to produce the beam design report. So once I click here, you have to wait for it to load. I'll just go here right now and click on this place, say load legacy for beam design, and then click on this place here, say okay, and then once I click on okay, I have to wait for this thing to read. As you can see that it is trying to read to 31. So I'll wait for it to finish up right now, as I'm doing just now. Okay, so you can now see that this is now the beam design report. I can see it there. So this is the beam design report for foundation, as you can see there right now. So this is how to produce your beam. So you can also see our beam reinforcement, as you can see there from the report. Top reinforcement 3x16 and the bottom 3x16, and sidebars you can see there are 5. So this is how to produce the beam design report. If you check all what we have done so far, you'll be seeing that, and also you can also see for this differential check it is okay, and okay, and also for the link reinforcement Y10 at 300 spacing, as you can see there. So this is how your beam design report should look like. Very perfect. That's why I say you have to check your beams one after the other. So you can choose to just send it to like PDF immediately, or you can choose to print. For like PDF, you can just click on this place called PDF and then wait for it to load for PDF, and then once it has loaded, you can now go ahead right now and then move to that. Okay, so let us hold on for it to load for the PDF just now. Okay, it's taking longer time because it will have to go open it on the software. Okay, so let me just go here right now and then close this first. So that's just how to produce your beam design report for Raft Foundation. And then with this right now, I'll go here right now and click on this place to say close here. Now on the closing right now, to now produce your slab Raft, your slab report also, go to this place here. To this place here, which is the foundation here, which is this place here. On this place, click on this place, right click, and then say slab analysis and design to produce the slab report for this Raft foundation. So click on this place just now, and then on this place right now, click on this place, just go here and then click on this place here, say design, and then wait for it to load up. So once it for the slab strip to for the report to like load up. Okay, they just hold on for it to come out just now, and then it will be out just now. Okay, the reason why I didn't check here is because I've already checked that before, and we have already designed our slab and showed our slab reinforcement. So right now I'm trying to produce the foundation slab reports. Okay, so let me just hold on for it to come out just now. Okay, So you cannot say that this year we have tried. Last year we didn't do much on Raft Foundation because we were trying to deal with pad foundation. And if you check our video last year 2022, we did more video on pad foundation. So we have treated all aspects of pad foundation. And this year we will be doing a Raft foundation for buildings on Raft foundation, and also for white strip foundation. And then later this year, at the end of this year, we will not introduce pi, which will not go more full on pi foundation on the year 2024, and then we will not begin to design for high-rise building for up to 10-story, 15-story, 20-story building for 2024. Okay, so Ekidel here, we have a lot of packages to train future civil and structural engineer. Like I told you before, here is where students, after your studies in your various schools or college or high schools, or let me say university, you have to now come to this place and then brush up yourself on Ekidel. Okay, so right now you cannot see our slab report. So this is what you know that your slab report is okay. You will begin to see this thing sufficient. If it's not sufficient, you will see insufficient. So you will begin to see it and also see your slab deflection check and see that L over D it is insufficient, as you can see there, and also see your slab reinforcement. This is showing Y12 at 250 spacing bottom, and this is also showing Y12 at 250 spacing top. So this is how it looks like. So you can choose to send to like PDF or print, or this one Microsoft Word, or even image. So right now I'll just go here right now and then click on close. You can choose to send to PDF if you want. So I will go here right now and click on close here. And then this one was opening for the bin. As you can see that this is now time for the one that we did for bin to open. So this is how you cannot see that it has come. Let me just increase the zoom, the visibility. Okay, so you cannot see for the beam. So we have now transferred it onto PDF, as you can see there, foundation beam design PDF.pdf, as you can see there right now. School building, as you can see. So this is now the foundation, as you can see there right now. So this is how it looks like. So you can choose to print also or save immediately on your assistant, and then but we'll just go here right now and close this right now, and then cancel this also. So if I check on our 3D view right now, we have come to the end of this part 2, which is the Raft Foundation design. So you cannot see what we have just done so far by designing perfectly this Raft Foundation. So this is how to design a Raft Foundation in Protastructure. This is the full one. Now on the part 3, we will be going into foundation detailing, where you will see, I will show you how to connect these two slab and this being reinforcement together, and also with the top, this slab reinforcement here. So I will show you also on that, and I will be using the Stonebridge company template release 2023. Now Stonebridge has two templates. It has last year, which is 2022. Now the one that you will be able to see or use for Raft Foundation and for Pi Foundation and for Pi Foundation and for all type of foundation is the release 2023. So if you want that, check on the link down below and download that template, because on the part 3, that is what I'll be using for the slab detailing for this building entirely. We will have to detail for the columns also. I'll show you everything about that, and then you will see how this template will help us to perform the slab detailing after Protastructure, and also to perform the foot detailing after Protastructure design. Okay, so right now, thank you so much and God bless you. We love you, and if you have any questions so far, I will say you should check on the link down below and then comment your questions so far. And please, like I said again, our vision this year is to launch a software for Ekidel. Is to launch a website for Ekidel. In that course, it will make us spend a lot of money to launch that. So we have just created a link which is like a support link. So if maybe you love Ekidel and then you want us to continue what we are doing, I would say you should please use the link below and then support us. You have to put the amount which you want to support by yourself. It is like an open price area where you have to put the amount which you want to support us, and we will be very, very glad to have your support. So thank you so much and God bless you. We love you, and see you again tomorrow for the part 3 of this Raft Foundation design. So thank you and goodbye.